called the ambient vibration or set vibration or temperature changes or anything. So all the time something is disturbing the poor structures. They can never rest in peace, right? So to speak. So all the time the structure is being disturbed, and being disturbed by loads, vibration, settlement, temperature changes, and anything else. It's always disturbing them. And when they are disturbed, what do? They respond, they react. Resist or not is a part of that, but they respond. Every time we excite somebody, they will react. Somebody said that a long time ago, to every action there is a reaction, opposite and equal reaction, right? Who said that? Yeah, good friend Newton. So, good friend Newton did not really know structures. He just said that in a global manner. But that is true. When you excite a structure, it will respond. And it will respond in a multiple manners. It will produce displacements, strains, stresses, stress resultant something. So this is the response from the structure based on the excitation that you give the structure. So if you excite the structure, it will produce a response which will be one of these. Our job as structural engineer is to find these responses based on the excitation. That is our most challenging task. That if the temperature has changed from 2 degrees or 5 degrees, what is the bending moment in the slab? What is the stress change in the column? What is the stress change in the footings? How much response is produced? That is our job. And that is very important because we have to know that to design the structures. So the main job of the structural engineer is to calculate the response for excitation for a structure. This is a very difficult thing to do until the computer programs came in. But anyway, this is still our main challenge. So after we get the response, we will do something with that. Let's see. So why do we need analysis? So analysis is the process of calculating the response to excitation. So if somebody asks you what is structural analysis, you can say it is the process to determine the response of a structure to excitation. Instead of saying calculate bending moment for loads, we have not generalized it. Like I said, you have to forget about all the older definitions. Analysis is not calculating bending moment for load. Analysis is determining response to excitation. General, it can be anything. So we generalize it, like I said. Why do we need to do that? We need to do that because we need to control the response. We cannot let it respond without control. So let's say we calculate that if the earthquake will come, the building, or if the wind is blowing, the building will deform by 10 centimeters. Is that good or bad? We have to decide. Is that enough? Or it's too much, or too little? If it is too much, how can I reduce it? How can I control it? So it is always the control of the response that we are interested in, because we cannot let the structure respond without control. Otherwise, it will get out of control. Then we don't know what it will do. It will collapse, it will move away, it will deform, it will crack. We don't want that. We want to control the response of the structure. And that part is called design. So the first part is called analysis, in which we determine the response, and second part, where we control the response, is design. So analysis and design go hand in hand. They are two faces of the same coin. One side analysis, one side design. So that is analysis, that is design. Right? We are not going to study analysis in this course. We are going to study design part. So we are going to assume that somebody has already determined the response and given the response to us. How can we design the structure for that response? That's this course. Next course, tall building design, we will do both. We will also do the analysis, we will also do the design. Using the information that we learned here. But my experience is that by the time you start second course, you would have forgotten everything that we teach in this course. That's the sad part. Because when I go to next course, when I ask you any question about this course, you will not remember. I have to repeat again. unfortunately. Anyway, so what is this equation?
Strain.
What is this equation mathematically? What is this called? Such equation, what are they called? It is written there. It's partial differential equation. Just read it, please. It's a partial differential equation. I put it in quotes so you can read it quickly, but you didn't. Right? It's a partial differential equation. How many people like to solve partial differential equations as a hobby? No one? I'm so surprised. Yeah, actually nobody likes it except mathematicians or some people. I know a few people who really like to sit down and they have nothing to do this solve partial differential equation. Anyway, these are very difficult to do, and they can only be done for simple structures and simple conditions. So the real response of the structure can be determined accurately through partial differential equations that mathematicians have developed for us. But in practice, it is very difficult to solve them. And structural engineers that I can see, they don't like to do it so much. Right? They don't even know it's called a partial differential equation to start with. How can they solve it? But this is not the right approach. I mean, this is the right approach. It's not a practical approach. We have to find some other way to determine the response. So if we wanted to calculate the response, you should follow the, if I ask you to explain this equation, maybe too much, right? Although you should know, you should have known. So what we do is shortcut. Because we cannot do that, we have developed shortcut. Structural engineers are very lazy people, I must say. We like to do a lot of shortcuts in our work. One of the shortcuts is that we cover the structure by a model. We convert the structure into a simple model because it's too complicated. For example, this bag, if I wanted to determine the response of this bag to load, that I'm going to lift it up and I want to calculate the stresses everywhere, it is too complicated. Can you do that? If I give you assignment? That if I lift this bag like this.
So you try to make it simple straight.
Yeah, I know. Can you find the stresses? It's too complex. Look at this. You will say it's too complicated. So you will try to simplify it like a strain diagram, something like that, and you will try to make some assumption. That's what we normally do, engineers. We try to simplify things and convert them into what we call structural models, which are not real, but they are supposed to represent the structure. And then we analyze those models, not the structure, because the real structure is way too complicated for us. And we also simplify the excitations, we also simplify the response, and we simplify everything. So undergraduate is all about simplification, extreme simplification. Now we are going to remove some of those simplifications and go back to a little bit higher level of doing things. Okay. So anyway, computer models are created and we determine the response of that one. So please remember one thing, very important. You are never determining the response of a real structure unless you are testing it. If you test it, then it's okay. You make a structure and you test it and you measure it, then you are actually determining the response of the real structure. Dr. Panchal likes to do that a lot. Most of his theses are testing. So if he wanted to find the stresses in this bag, he will put strain gauges everywhere, then he will hang it, then he will tell you strain is so much here because he has lots of strain gauges and he can measure the response in every location, right? So that's great. But we can't do that for a structure that hasn't been built yet. As designers, we are dealing with a structure that has not been built. So how can you measure the response of a structure that has not been built yet? Correct? So what do? Model. You create a model. You make a simplified some model and you based on that model then you design it. When you construct it, then somebody can go, Dr. Panchal can go and measure it. Right? But in the meantime, we have to think of how to design a structure before it is built to make it look good. Now this is the, okay, I still have 7 minutes. This is the basis of structural hearing. Very, very basis of